Welcome everyone. In this video, we will derive an expression for the equivalent resistance of two resistors in series. I mean in parallel, right? Because in the last video, I derived the one for series, so I'm going to derive the one for parallel right now. So here we go. Now, if two resistors are in parallel, this means that the voltage across them is the same. This is by definition right, okay? So as you can see from the diagram, if I name this one R1 and this resistor R2, you can see that the voltage across them is the same, so they are in parallel. Well, how could I find the equivalent resistance of these two resistors? In other words, if I were to replace this system of two resistors with one resistor, what should the resistance value of that resistor be? So what is R equivalent? Just like the previous video where I derived the equivalent resistance of two resistors in series, let's start with what we know. So we know that, as I said, the voltage across these two resistors will be the same. So V1 is equal to V2, and this is also equal to V. Let me label the things that I mentioned. So let's say that we have V1 right like this, V2 like this, and V like this. So these are equal to each other. And what else do we know? Well, we know that if we have a current I that is coming through, excuse me. All right. If we have a current I coming through, it will split into two, so that if we label this one I2 and this one I1, it will split into two, and this means that I1 plus I2 is equal to I. And this is actually enough equations to derive a formula. And of course, we also need Ohm's law, right? And now we're ready. We actually are ready right now. So I will call this R equivalent, because that's what we are looking for. So the voltage is equal to I times R equivalent. It is also equal to V1, and it is also equal to V2. Right? So using using this identity, this equation, we can say that, again, extending Ohm's law, we can say that instead of V1, I1 times R1 is equal to I2 times R2, right? And if we solve for, I don't know, let's say I2, if we solve this equation for I2, we get that I2 is equal to I1 times R1 divided by R2. Okay, so we got this one right. Then let's move on to another equation. Let's move on to do more manipulation. Maybe we could consider this part of our equality now, the green part. And from the green part, if we want to solve for R equivalent, what we can do is we can first write the right side as I1 times R1, then we divide both sides by I, so that we have R equivalent is equal to I1 times R1 divided by I. Now, here I said that I is equal to I1 plus I2, so let's just substitute that. Great, this is what we get. And look at what we have. We also have an expression for I2, right? It is the equation that we found in red, this one. So let's substitute that one as well. So instead of I2, I am writing I1 times R1 divided by R2. Well, let's let's add the two terms in the denominator. So we need to make their bases the same. Not the bases, excuse me. We should make their denominators the same. So we get this, right? If I add these two and combine them under one denominator, this is what I get. I mean, above one denominator. Sheesh, I'm real bad at explaining myself today. But anyways, and it is a property of multiplication and division that we can bring this R2 to above, right? So we can write that I1 times R1 times R2 divided by I1. Oh, by the way, this is I1 here as well. I forgot the subscript. I1 times R2 plus I1 R1. And now if you divide both sides by I1, you divide both sides by, not the both sides, if you divide the denominator and the numerator by I1, these cancel and you are left with R1 times R2 divided by R1 plus R2. And this was equal to, as you can remember, R equivalent. So we have derived an expression for two resistors in parallel. For their equivalent resistance, let's say we want to find the equivalent resistance of two resistors in parallel. All we do is we multiply their resistance values and we divide it by the sum of their resistance values. I know that some people, might confuse this. Some people might confuse this. This formula, because, is it R1 times R2 divided by R1 plus R2, or is it the other way around? Is it R1 plus R2 divided by R1 times R2? Well, there is a very, very simple way to remember which one it is. You just do a dimension analysis. So you look at the units. The unit that we have on the left is ohms, right? We have ohms here. And on the numerator here, we have ohms squared. Divided by ohms plus ohms is ohms, so that we get ohms again. If we were to do the other way around, if we were to have R1 plus R2 divided by R1 times R2, then the unit of the right side would be 1 divided by ohm. And this is, of course, not equal to an ohm. And this is a way that you could, remember this equation. You don't need to be confused about whether you divide the sum by the multiplication or you divide the product by the sum. No, you can always check yourself, or you can even go through the derivation yourself. I hope that you found this video helpful. If you have any questions, please write them in the comment section below. I hope to see you in another video. Until then, take care.